So I've made some space up here because what I want to do is insert another chunk, and there's a few ways you can do that. You can go to Insert and click on R, and that'll give you a chunk. You could also just type, this is the, I don't know what the name for it is, but it's the tilde key. Hit it 3 times for the not tilde, and you want the curly brackets, R, and you also want to close that with the same 3 accents, or accent marks, I guess it is. So that also makes a chunk. Now what I want to do is talk a little bit about packages, right? So R is kind of like the ditto of stats programs. It can kind of be whatever you want it to be. If you want it to be a cartographic analysis program, you can download the packages to do that. If you want it to be something that's, that does more Bayesian analyses, it can do that. You can find different things for that. If you want to use it for multiple imputation, there are programs and packages for that. So you can make R whatever tool you need it to be by installing packages. And one big one that we want to do, well, there's 2 of them actually. The first one's going to be Papaya. Papaya is going to be very important, and Papaya is a little bit different because it's in alpha, and so you can only get it off of GitHub. So what we're going to do is, first thing we're going to do is install something called DevTools. Install.packages, DevTools, and we'll run that. And you'll see in the console, we have successfully unpacked, everything worked, we downloaded the binary packages for DevTools, everything is all set. So now that we've installed it, we don't want to run that every time we knit this file, right? Because knitting a file is literally just running through the whole thing. So in order to kind of say, okay, installing is good to do, but we don't want to do it every time, we can hashtag it out. So when we hashtag it out like that, that means that yes, the code is still there, but we're not going to run it every time we get to it. If you want to run it, you just delete the hashtag. Very easy. Okay, so we've installed DevTools. Now we want to install Papaya. So I don't have it off the top of my head how to actually install Papaya. So what we're going to do is we're going to trust the old Google machine. P-A-P-A-J-A download. And here it is. So Papaya stands for Preparing APA Journal Articles. P-A-P-A-J-A. And what we do, so when you Google it, you get to their GitHub, and you come down here, and it gives you the installation requirements. So you need R, RStudio, and a tech distribution, which we did, right? These are all the things we have. So now we have to install Papaya. So we take this code here, so DevTools, : install GitHub, CRSH Papaya. Take that, come over to our RStudio, and we're going to run that. Now the same thing's happening. We're downloading Papaya from install_GitHub function. So you'll see that it runs, it runs, it runs, and it runs. It's still going. And there we go. Done. So now we have Papaya. Now Papaya, we'll have to close out of R and open it back up to actually show you what's in there. But there's one other thing we want to do, and this is going to be the more normal way you'll install packages. We want to install.packages tidyverse. So tidyverse is a collection of packages that very much changes the verb and kind of language of R to make it a lot more digestible. I learned R using packages that became tidyverse, so these packages are called things like dplyr and ggplot for making graphs. So tidyverse will take all of those packages and put them all together, and it will give you the language that we'll use to analyze our data. So we install our packages, installed tidyverse, and I'm running out of time here, so I will hashtag that out, and now I will library Papaya and library tidyverse, And now this I want to run every time. This is saying I want to use these packages in my code. So here you can see all the packages: ggplot2, tibble, tidier, reader, per, dplyr, stringer, and forcats. And we also have dplyr filter and dplyr lag, which mask a filter and lag function that come from the stats program. That's what this is telling you. So dplyr filter and dplyr lag mask stats filter and stats lag. Don't have to worry about it right now. We're not going to use those, but that's what this is telling you. Cool. So just very quickly, we'll look at a little more data. So let's make a new chunk. Now, in our paper, we're going to be looking at the iris data set. And the iris data set is one that already exists in R. So we don't have to read a CSV. It's kind of already baked in there in base R. So you can see here, just by doing iris is iris, we have iris here as a data set of 150 observations of 5 variables. So we have sepal length, sepal width, petal width, and the species of iris. And there's 3 species here. So there's one final thing I want to talk about, which comes from the tidyverse, and it's called the pipe. And that is something that looks like this. The key shortcut is Control-Shift-M on Windows, and I'm pretty sure it's Apple-Shift-M or Command-Shift-M on Mac. It's one of those. It's 2 left-hand keys and an M. The pipe is what's going to fuse all of your language together. Let's give you an example. Iris, that's my data set. I'm going to now pipe from my data set, iris, some function, some verb from the tidyverse. So let's say something like filter. And I want to say that species, see how it autofills like that? Species only equals, let's see, setosa. And since it's a string, you have to put it in quotes. So if I do that, now I have the data only for setosa. So I have 50 rows. It's 50 observations of setosa. Or let's say I wanted to do iris pipe filter species does not equal setosa. I can run that. So now I have 100 rows with versicolor and whatever the other species is. So here is how you start building the language that will become your data analysis.